Hi, and welcome to the video on related rates of change. A spherical metal ball is heated so that its radius is expanding at the rate of 0.04 millimeters per second. At what rate will its volume be increasing when the radius is 3.4 millimeters? Let's start off by working out what they want us to find. They want us to find the rate that the volume is increasing. So we want to see the change in V, volume, with respect to time. We know that we're going to have to look at the volume of a sphere because we have a spherical metal ball that's been increasing. So I'm going to differentiate the volume formula to get 4 pi r squared. This will give us the rate that the volume is changing with respect to r. We also have from the question that the change in radius with respect to time is 0.04 millimeters per second. We can now use the chain rule in order to work out dV dt. So I'm going to replace in the chain rule dV dr with 4 pi r squared and dr dt with 0.04. Multiplying those two together, I get that dV dt will be 0.16 pi r squared. Now that r is still a variable, so I know from the question that r is 3.4, or at least that's what we want to find the rate when the volume is increasing when the radius is 3.4. So subbing that into my dV dt, I calculate my answer as 5.81. So I should write a worded answer for a worded question. So the volume will be increasing at a rate of 5.81 millimeters cubed per second. Let's take a look at another example. A pool holds a volume of water given by V equals 2x plus 3x squared, where x is the depth of the water. If the pool is filled with water at the rate of 1.3 meters cubed per hour, at what rate will the level of water be increasing when the depth is 0.78 meters? Let's start with what we want to find from the question. We want to know what rate the depth is changing. So depth is being represented by the letter x, so we want to know the change in x with respect to time t. We're given the volume of the water as V equals 2x plus 3x squared, so I'm going to differentiate that formula in order to get a rate of 2 plus 6x for the change in volume with respect to the depth. Now from the chain rule, I know that dV dt will be dV dx times dx dt. So my question gives me dV dt. It gives me 1.3 meters cubed, which is the change in volume with respect to time. That's going to equal the change in volume with respect to x multiplied by what I want to work out, dx dt. Now I know that x, the depth, is 0.78 meters. So I'm going to substitute 0.78 into my formula. I'm going to rearrange so I can get a value for dx dt. So the change in volume with respect, the change in depth with respect to time is going to be 0.195. Again, I'm going to write a worded answer to my question. The level of water will be increasing at a rate of 0.195 meters per hour. I hope these two examples helped you with related rates of change. As always, refer to the text if you need extra help. Good luck.